Hi, thank you for your interest in this work. My name is Hyun. Today I'll be talking about an interactive prototyping platform for collaborative spatial design exploration. This is a joint work with Kihoon, Hwiwon Chun, and Sojin Park, and it was done at Hanyang University. The most important spatial design ideas, project principles, and fundamental design decisions are developed in the earliest design phase. Spatial design projects such as architecture and interior design begin with conceptualization that includes abstract diagramming, zoning, and massing to provide foundation for making design decisions as shown in the figures below. Abstract diagrams guide designers to explore alternative designs without focusing excessively on details. Also, abstraction aids design creativity and helps designers to transferring only the essential relationship of the design properties. However, ambiguous and incomplete designs can cause communication issues when presented to collaborator. Therefore, designers devote significant amount of time and resources into searching for design references and developing rough prototypes to refine their design concepts. We identified 3 limitations for current design exploration process in spatial design. First, design communication is crucial to design process for facilitating accurate delivery of information. However, abstract diagram sketches in the early design stage cannot convey the intent of the designer effectively. Second, creating a physical prototype of a spatial design requires time and resources. Physical models facilitate not only the communication to design collaborators and customers, but also the examination of design ideas and decision-making. Third, traditional design reference search methods are unsuitable for obtaining spatial design data. Spatial designers must consider various elements such as user requirements, room properties, and room connectivity. Currently, designers primarily use relevant textual terms to search for references through Google Images and Pinterest Images. Thus, this study proposes C-Space, an interactive platform that assists users in exploring spatial design ideas through tangible user interface and augmented reality. The interactive design process through C-Space involves the following step. A. Retrieving design references through a graphical user interface. B. Discussing and altering retrieved references through a tangible user interface. C. Testing finished materials using projection mapping. C-Space is a design support system that stands for Collaborative Space and C-Space. It consists of 6 major components. First, physical modeling components. Second, design reference and data analysis. Third, 3 design reference retrieval methods. 4, material simulation. 5, design alternative management. 6, export to BIM file format. C-Space supports a TOI environment for physical modeling in architectural design, scaled down to 1/30. The physical modeling component consists of modular building blocks, room marker blocks, numbering interface, and grid board. The modular building blocks are used to assemble walls and rooms, and the room marker blocks are used to indicate the room types. A magnet with a diameter of 3 mm was installed at the bottom of the blocks to prevent them from falling apart. The building blocks have infrared reflective stickers on the top to enable automatic wall detection. The room marker have color stickers. Each color indicates a room type. Balcony for green, bathroom for blue, living room for red, entrance for pink, bedroom for yellow. And the grid board was made of steel. The grid board could be rotated 360 degrees, and the AR marker on the grid board was used to detect rotational angle to responsibly map design reference and finished material on the rotating grid board in real time. The numbering interface left to the grid board consists of 1, 2, 3, and 4, and more areas. Once the room marker blocks are placed in the numbering area, C-space recognizes number of the input room types. For design reference data analysis, the residential building design references were used as a retrieval data. We collected 13,312 floor plans of residential spaces in Seoul, Korea from a web-based real estate database. C-space supports 3 retrieval methods. First, shape-based, second, number of rooms-based, third, room connectivity-based methods. A C-space user can search for a floor plan reference with a similar shape by assembling the outer walls on the grid board using building blocks. In this case, users do not need to complete the outer walls of desired shape. Users only need to assemble the corners of the desired shape on the grid board. To search for references using the number of rooms-based method, users must input the number of rooms per room types by placing the room marker blocks on the numbering interface. Then, the webcam detects the room marker and processes the number of rooms-based retrieval method. In the room connectivity search, the entire dataset is first filtered based on connectivity. The purpose of this filtering operation is not to perform graph matching to obtain data identical to the user input, but to perform subgraph matching to obtain data including the user input. These 3 methods can be used in parallel. Once users complete the assembly of the building block, materials can be simulated on the physical model. Users can select and apply finishing materials by using C-space GUI. When the mapping button on the GUI is pressed, the system reconstructs 3D walls by using 2 adjacent points among the assembled model inputs. And a floor plan is created based on all the corners of each room. Then, pre-installed projectors map the reconstructed 3D model with the material texture to the assembled building blocks by adjusting camera FOV, viewpoint location, and rotation. And users can save design alternatives that they create. 3D model, material data, floor plan references, and histories used to complete the design alternative are saved. Additionally, users can track design generation history. Also, C-space supports guide projection on the grid board to help users in remodeling the saved design alternatives. The design alternative created with C-space can be exported to BIM file format, and the outcome can be exported as an Revit file, which is an extension for Autodesk Revit. Implementation results. The C-space was implemented in the predefined lab test condition. C-space requires pre-installation of the 12 equipment listed in this slide. We have cameras, computer, and 3 projectors and physical modeling components. And to test the impact of the proposed system to designers, we conducted user studies. Novice designers and professional designers were invited for user experiment, which lasted approximately 4 hours. The participants were grouped into teams, and each team comprised 3 members, and a total of 4 teams participated in this experiment. And each group performed a design task based on a design brief. There were 2 types of design briefs. First is a house was to be designed for a retired couple who use wheelchairs and their 2 daughters. And second, a house was to be designed for a young couple and a little son who requires a room for piano practice. And despite different design approaches, both novice and professional groups shared positive responses to the impact of C-space. According to the in-depth interviews with the 12 participants, we categorized 6 advantages of C-space. The first advantage is assisting rapid spatial design exploration and development. Users commented that C-space allows them to make team design decisions much faster than the traditional methods, even in the early stages of design. For example, users can search design reference and explore design alternative, modify design alternative, and checking the new design alternative on the target design site very quickly. So the designers can rapidly go through multiple iterations to explore more optimized design solutions. Second advantage is experiencing space and scale. Users commented that the design outcome assembled with the modular building blocks was effective in communicating and modifying designs among the team members. For example, a user explained design ideas to team members. With the modular building blocks, users were able to predict the room size. The modular building blocks made it easy to measure the size of the room along with the wall thickness and the width of the corridor. The third advantage is developing details in the early stage. C-Space can assist designers in developing design ideas in the early design phase without a concrete design concepts. Designers can search design references gradually depending on the input condition. While users were exploring design references, they get new design ideas from partial layouts from various references. For example, a professional design team was designing for a retired couple in a wheelchair, and they got an idea of arranging every rooms connected to a long aisle in order to help the couple to move around more efficiently. Fourth advantage is inducing collaborative discussion. We observed that discussions were actively conducted in all 4 teams, and these discussions accounted for 73% of entire design experiment. The in-depth interviews also revealed that C-Space promoted a collaboration regardless of relationships among participants. For example, participant 10 said, "I was working with stranger and it was awkward in the tutorial. However, we felt like we were getting closer as if we were assembling modular building blocks together like a Lego." And participant 11 said, "It was possible to design and evaluate models together without knowing the personality of the working style of a team member, so there was no problem in collaboration." So C-Space motivates multiple users to collaboratively develop design ideas by modifying retrieved design references partially or entirely during the early design phase. The last advantage of C-Space is the integration of early design phase to later design phases. According to participants' responses, the design alternative management feature to archive design references was helpful. This feature helped designers to review previous concepts for references in the later design stage. For example, when the design was developed and users faced design fixation, they were exploring design alternatives that they designed previously. The users reviewed previous design alternative along with the design reference history to re-evaluate why they did not develop the alternative further. So therefore, creating a large set of possible and reliable design alternatives and references was useful to simulate knowledge acquired from the early design phase to use the same in the later design phase. So in conclusion, this study proposed C-Space, a novel design support system for interactive and collaborative spatial design exploration. There are 2 major contributions of the study. First, we created an interactive platform on collaborative spatial design exploration, and we believe that C-Space represents a novel contribution in this area of interactive exploration of large collection of design references, particularly those with information on spatial layout and connectivity and shape. Second, C-Space offers a collaborative design platform with the integration of useful features, including design reference exploration using AR and prototyping using TUI, that could enhance collaborative processes and produce satisfactory design outcomes. C-Space can be an example of an integrated collaborative system that motivates designers to interact with designs. So if you have any questions, please feel free to email me. Thank you.